Hi guys! Welcome to Digital Modulation. I'm Randy Bartolome from Quezon City University College of Engineering. Today, we will discuss about differential pulse code modulation, also known as Dpcm. We will talk about its advantages and how the encoding and decoding is processed. So, let's start.
Okay, now let's compare first the difference between PCM and Dpcm. For example, we have a bandwidth rate of 2. So in PCM, lahat ng information regarding that data will going to be transmitted. So it requires large memory for encoding. Unlike sa Dpcm, we only take the difference between each data, or known as error datas, that will going to be transmitted. So in this particular modulation, the memory for the encoding will going to be lesser than the PCM. Even if we have a multiple series of datas, we only left with minimal memory for transmitted encoded signals. Okay. So yung Dpcm, from the name itself, ang dinidistinguish natin dito is yung difference between the data or labels na kinukuha natin. So for example, we have a larger bandwidth. So kapag mas marami yung bandwidth, yung mga level, for example, let's say we only have for 1 seconds required time. So magiging condense, mas magiging dense yung mga levels nung mga datas, at saka mas mabilis nating makaka-classify yung relativeness nila between each other. So sa differential, kinukuha natin is yung difference nila. So let's say we have in A, we have 3.1 voltage. In B, we have 3.3. In C, we have 3.5 voltage. In D, we have 3.4 voltage. In E, we have 2.9 voltage. In F, we have 2.4 voltage. In G, we have 2.5 voltage. In H, we have 2.4 voltage. In I, we have 2.9 voltage. And lastly, in J, we have 3.1 voltage. So ano ibig sabihin ng kinukuha natin yung difference? So by the means of kinukuha yung difference, nileless lang yung difference ng A and B, which is, if we're going to subtract these two values, we're going to have 0.2 voltage. In B and C, we have again 3.3 minus 3.5, we have 0.2. In C to D, we have 3.5 minus 3.4 is 0.1, and so on and so forth. So by analyzing the consecutive values that we get, it's easy to determine that Dpcm requires only minimal voltage than the original levels. So kung mas maliit yung bandwidth, mas mabibilis, mas mapapabilis yung transmission ng signals from analog to digital and vice versa. Okay, in this part, we will discuss how Dpcm encoder process from analog into Dpcm output or digital output. Okay? Yung analog input is papasok dito sa sampler. So, kapag nandito siya sa sampler, siya ay magiging quantized input. Kasi papasok siya dito sa quantizing agent. Tapos, from quantizer, ito naman yung error quantized output. So, dahil palabas siya ng quantizer. Ito na yung product ng quantizer palabas. Okay? Yung error quantized output is pupunta siya sa represented by X, Q, and TS, which means siya ay prediction filter input. At yung X, cap, and TS is symbolizes the prediction filter output. So, ganyan lang nagpa-process ang analog to digital output ng Dpcm. So, to find the error signal, kasi nga, yung analog, dinifferentiate natin siya, lumiit yung bits, yung binary digits niya, na tanggal yung mga redundant digits, at pinaliit natin siya using the quantizer. So, paano nga ba nakukompute yung error signal? So, sabi dito, yung input, ba't namatay?
SQNR of Dpcm or Signal to Quantization Noise Ratio. Ito yung block diagram ng SQNR. Magsisimula siya sa input signal, which is x of t, and dadaan siya sa sampler, which is magiging x of nts, and yung difference ng sampler and yung prediction filter or yung x cap of nts ay magiging e of nts, which is ito yung error. And then yung error na to dadaan sa quantization na magiging eq of nts, or ito yung magiging quantized error. And then yung EQ NTS and plus yung output ng prediction filter ay magiging XQ of NTS. And yung XQ of NTS na to ay pag na-filter, na dumaan sa prediction filter, magiging X cap of NTS. Then yung EQ of NTS, once na dumaan siya sa encoding, ito na yung magiging Dpcm signal. Ito yung formula ng SQNR, where SNR output is equals to sigma x squared over sigma squared q. Saan yung sigma x squared ay yung variance ng original input-output or yung sa sampler, and yung sigma squared q ay yung variance ng quantization error, and yung sigma squared e ay yung variance ng prediction error. Dito natin makikita yan. Ito yung x, yung sigma x squared and sigma squared e and yung sigma squared q. Yung formula na to pwedeng ma-write gamit ang sigma x squared over sigma squared e, which is yung GP, and times mo sa sigma squared e over sigma squared q, which is SNR P of P, where yung GP is prediction gain produced by differential quantization, and yung SNRP ay yung prediction error to quantization noise ratio. So, yung formula is magiging SNR output is equals to GP times SNRP. Para mapa-increase yung SNR output, kailangan ng GP ay greater than 1, where yung GP is sigma x squared over sigma squared E. Para makontrol yung pagtaas ng GP, either increase natin yung sigma x squared or i-decrease yung sigma squared E.